Welcome to another CMC podcast. The purpose of our podcast is to get our listeners to think about and discuss different rescue topics. In some cases, you may learn about a new technique or even different disciplines within the technical rescue community. As a result, you're going to hear different and even sometimes opposing opinions from our instructors and our guests. You may or may not agree with them. The key is to keep an open mind and use that information to help guide you to make decisions about your techniques, training, and policies within your own organization. In this episode, we talk with Clara Acuna of the Army Corps of Engineers at the Ice Harbor Lock and Dam in Washington State. So we're going to begin the discussion by understanding the many different missions of the dam. Then this directly impacts the types of rescues that the in-house rescue team must be trained and equipped to handle. I'd like to welcome everyone to another CMC podcast. Today joining us, we have Clara Acuna from the Ice Harbor Dam, which is run by the Army Corps of Engineers. Welcome, Clara.
Well, thank you for having me.
So, Clara, why don't you tell us a little bit about yourself, kind of where you started and how you got to where you're at?
Well, I guess in a nutshell, kind of going back in time, I was actually born in El Salvador in Central America. I lived there till about the age of 6. And just a little background, there was a civil war that had been going on in El Salvador from the 70s all the way to about 92. During that period, my parents felt it was unsafe, so we left El Salvador. We ended up in Miami, Florida, and that's pretty much where I grew up from the time I was 6 to I was 18. I went to high school there, graduated, and I wanted to go to college, but my parents just were not financially able to help. Living in Miami also, there's not as many opportunities as one would like, for trying to get yourself into college on your own. So the best I could do was I enlisted in the Air Force. So I joined the Air Force. I spent 8 years there as a medic. I've worked pretty much every section of a hospital you can think of, from, doing a post-mortem care type of activities to ICUs. The ER is where I spend a lot of time. I was an EMT. 8 years of that really starts to take a toll on you. I felt I needed a change, so decided to leave the Air Force. And then I moved to Boise, Idaho, and I went to college at Boise State University for what seemed like an eternity. It was like 5 years, but it really felt forever. But finally graduated. I have a BS in environmental and occupational health, but the program was very industrial hygiene focused. So not so much safety. When I left Idaho, it was to move to Walla Walla, where I live now. And I worked for the Corps of Engineers as a safety specialist at Ice Harbor Lock and Dam.
Yeah. What else did you do while you were in college?
Oh, man. So I worked full time at a hospital, and I worked in the lab there. I worked in the microbiology lab. I did central processing there. I was a phlebotomist. I also worked in the ER part-time. And then I went to school full-time. And that's pretty much all I did, was just work and go to school.
Wow. Yeah, that's you weren't bored for the 5 years, that's for sure. Huh?
No, I was definitely not. I was too busy and hadn't slept in what seemed like an eternity. So yeah.
But yeah, and so you ended up as an industrial hygienist. I mean, that's impressive. That's a very difficult degree. So
it was a lot of work in college, and surprisingly enough, here what I do now does pull from a lot of that. Mostly, if anything, all safety. But there's such a large industrial hygiene part of that, of the safety process, that luckily I actually know what I'm doing most of the time. So this is, it's great.
So you said right after college, sorry to interrupt there, but so then after college, you said you went to work for the Army Corps of Engineers then?
Yeah. In fact, I couldn't find a job in Boise for what I had a degree in. And I was lucky that a friend that I graduated with got a job here at the Corps. There was another opening, and he called me up and was like, "Hey, I heard you can't find a job. I got one for you." I applied, and here I've been since.
Excellent. So how long have you been at Ice Harbor then?
So Ice Harbor, I started with the Corps in 2010. And I got to Ice Harbor at the beginning of 2012. So I've been there, I think, almost 9 years now. But 10 years next year. Wow.
Where did you start in 2010?
So I was actually a Department of the Army intern. So that's how this position came about. It was a 2-year requirement that you had to be a Department of the Army intern. But my internship didn't last that long because there was a push to put safety specialists out at each of the dams. So I got to, leave my internship a bit earlier. But general safety, visiting the other dams, doing inspections, that kind of stuff is pretty much what I did as an intern.
Okay. We met while I was teaching a class there earlier this year, and I got to tell you, I was really impressed. Number one, with the scale of everything, and also just the multifaceted nature of a hydroelectric dam. I guess coming from the outside, I thought that a dam was, it held back water and you generated electricity, but that doesn't even scratch the surface of what you do, at the dam.
This is true. Huh? And in fact, you touched on two of our major, obviously we make electricity. That's probably like our biggest mission is we make electricity. But I think people forget that we also have a lock system. So we are part of the navigation system up and down the Snake River. We also provide recreation. We provide irrigation. We provide parks. We support and maintain parks that the general public can come out and enjoy. They can camp there. They can fish there. But we're responsible for such a large amount of area, Yakima River, Columbia River, and the Snake River. We are at the confluence. So there's a lot of responsibility just with what we do. And then to encompass that all, we also have fish passage, which is probably the second largest component of what we do is, ensuring safe travel for fish up and down the river, pretty much, whether it's through fish ladders or through barging or however that, the other dams take care of that. It's definitely a huge part of our mission.
Yeah, and maybe if you could talk a little bit and kind of tell our listeners what's involved. I was shocked at just the scale of the pumps and the water mains and everything, just for the express purpose of getting the fish to come over to the fish ladder, just to draw them in. If you could describe that process.
Well, so we have several ways that happens, but what you saw, I believe, is it's our adult. So the two giant fish ladders, we have one on the south shore and on the north shore. And so we have the ability for fish to be able to get up the Snake River through two different entryways. There's a fish attraction system basically that what I believe is it causes a certain type of water pattern that attracts the fish to come in. That gets them into the ladder system. The ladder system is basically, it's a way for the fish to be able to naturally climb up past the ladder through these segments that it's like a resting pool. And then it kind of looks like steps. So the fish can either go through a window that's cut out through the concrete, or they can, jump over they're like these diffusers, these big concrete structures that basically allow certain water patterns to develop in that area. And basically they just jump their way up the ladder and then exit up the river and keep going to their spawning areas. But that's for like adult fish. For the juvenile fish, we have a collection channel, which kind of comes from the forebay. So these are the fish that we are trying to get to the ocean. So they come in through our forebay and they go through this juvenile collection system that basically corrals them all the juvenile fish, into this pipe system that basically shoots them out the tail race area of the dam. So basically it's a way to take them from the backside of the dam and then move them around basically and get them forward so they can swim to the Columbia and then go to the river. Okay.
I found it interesting too when you were explaining how, like a lot of the mist and a lot of the turbulence in the water is actually where it comes out on the low side of the dam is actually done on purpose to protect the fish, right?
Yes. So this is the other component. You had mentioned the turbines. Some fish that get caught in that forebay system, another alternate way that they can get downriver is to go through the turbines, right? And so there's these wicket gates. There's basically what they do is they adjust the amount of water that can come through. it's a whole component of stay vanes, the wicket gates. They open and close to allow that water through, but basically it should let the fish come in through the turbine blades and then out the draft tube. What we have found as the Corps is that there are more efficient ways for that to be done now, especially with us at Ice Harbor. We've put in a new fixed turbine unit, and we're doing refurbishments to our main units 1, 2, and 3 to improve the actual design of those turbines. So when the fish do come through, there's less damage being done to the bodies of the fish that are just trying to get to the ocean.
Okay.
Yeah. So there's just a lot of technological advances that have come about for turbine design to allow safe passage for fish. So it's these two things coming together.
And we were kind of talking offline too. I think one of the incredible things is that when this dam was built in the late 50s, early 60s, that they had the forethought to put all these systems in, or at least the ability to grow if you can and modify what you're doing in time to stay current with technology. It's just mind-boggling the amount of technology that goes into moving fish up and down the river. But I guess that's a critical point to in any river.
Yeah. I mean, when you look at a lot of dams here in Washington State, and well, actually in the West Coast, really, there's quite a few that are managed by BOR, which is Bureau of Reclamation. They're kind of like the other organization in the U.S. that manages just as many or maybe even more dams than we do as the Corps. You can kind of see like the differences between their designs. Their designs didn't really incorporate fish ladders, whereas the Corps did. So there's areas now that, like Grand Coulee is a great example. The fish there, once they stop, like that's it for them. There's no fish ladders at Grand Coulee. So the new thing now is that they're finding like this system to basically shoot them over the dam. It's like a fish cannon, I believe. A salmon cannon is I believe what it's called, a salmon cannon. And they go in through this system that's filled with water. So they're never without water, but it basically sucks them through the low end and shoots them up over the dam to get them over. And that's not something that I've seen with the Corps, but it's definitely sounds like an interesting new technology for sure.
Yeah, it'd be interesting to see. That's for sure.
Yeah.
So one of the other things you mentioned was the lock system there, and I noticed that you have a very busy lock. I know when we were there teaching, there was a lot of not only barges for fuel, grain, everything else, but even a kind of a river tour boat.
Yes,
good sized one that was going through. So can you talk kind of what it takes to run a lock system?
Oh man, okay. So that's an interesting one. So all the dams on the Snake River have a lock system. So it's part of like the Snake River lock passage. And basically what that is, like you mentioned, we're getting stuff from all the way from Portland, into the Port of Lewiston. These are the areas where a lot of that material is going to, but there's also a lot of passage from stuff coming, from northern areas of Idaho that need to get on the river and make their way downstream. So all these dams, including all the Portland district dams that are on the Columbia, they'll have to talk to each other basically so they know what barge is coming and how soon we need to drain the lock to get them in, float it back up and get them to where they're going. Normally, it's like Tidewater, Shaver. It's mostly wheat or some type of grain. I've seen, all kinds of goods come through on the barge system, but it definitely is something that we have. Our operators are part of that. So when we get a call on the radio saying, hey, Shaver's coming upriver, they're going to be there in a half hour, then our operators have to time that. So it takes them about 12 minutes for that lock to drain and then also empty back up. So depending on the traffic, whether it's going upstream, right, we'd have to drain the lock to open up our big gate, get that, get whatever that cargo is in there. Then you fill it back up. It floats the cargo ship basically up into the water and then over into the forebay and then gets them going upriver. If they're coming downriver, we get the signal, same thing. We get them inside the lock, lower the water level all the way down, open the gate so then they can go downriver. So it's all very synced, but the operators have radios that they speak to each other up and down the river so they know what's coming basically and how close it is to that respective dam.
Yeah, I found it very fascinating to watch, how quickly you can move ships up and down, and how many feet of lift, or, how many feet of head is there in the dam?
Oh man, so
It's, I know it was right around 100, right? It was like 93 or
yes,
something. Yeah.
I want to say it depends on which area of the dam you are, but our lock alone, I want to say it's about 100 foot difference from the time that it's from the bottom, or if you were to like unwater it completely, then the distance increases obviously. But yeah, it takes a good 12 minutes to fill that up and down, and it's got to be close to 100 feet every time that it goes up and down because
Wow.
it's just giant lock.
Yeah. And then once we got inside the dam too, I was fascinated all the different tunnels and all the spots where you can actually go down, like right down to almost the bedrock layer underneath the water, like at the base of
Yeah,
the
the
dam.
grout gallery.
Yeah.
Yeah, that's the very, very bottom. And a lot of people are surprised when they go down there because they see leakage. They see water everywhere and dams leak. I think that's something that I think it's something people don't believe that you're a dam. Like, why would that be happening? But, it's holding back a lot of water, a lot of pressure. So, there's these relief pipes, I guess, that are in the bedrock that I think I showed you that they're embedded in there. And it's basically to allow the dam to kind of move with the bedrock as necessary, depending on, silt conditions or, heavy water. If we're in a flood situation, that's a lot of like silt and debris that's coming down on that river. So, the dams have to be able to accommodate like small movements to just be able to function well. So,
Well, and I remember you telling me too that even though it's a concrete dam, it can almost float too if you didn't allow that pressure to be relieved down there.
yeah, it would basically pick up and just float down river, which is scary.
Yeah.
Yeah.
It's hard to picture something that large floating down river, but I guess it definitely could happen. And I just kind of a side note, and when we were doing our classes, when you had that heat wave, I remember it was 117 degrees outside. So down in those galleries was a wonderful place to be.
Oh my God, it was. It really was, especially in the afternoons, because that one day that it was 117, I really thought we were all just going to fall out there. I was like, we need to get inside.
Yeah.
So, yeah.
Everyone was very happy to be down in that gallery. It was mid to high 50s, I think, down there, right?
Oh, yeah. Yeah. It was very, very cool.
So kind of one of the reasons I wanted to talk about all these different components and all these different facets of a hydroelectric dam, because that directly affects your position at the dam.
It does.
And which is, well, in addition to many other things, not only being in charge of safety, you're also in charge of the rescue team, correct?
I am. That's something that I inherited as I went to Ice Harbor as the new safety specialist, whereas before there was one individual doing both safety and environmental. And unfortunately, the safety portion just took a really far behind back seat because the environmental component has always been more visible for people. Anytime, one of the dams gets oil in the river, we're on the newspaper. It becomes a big deal, but nobody really thinks about there's a whole other component going on in there also. And that's all the work and all the safety, that goes along with ensuring that work gets done in a safe manner. Mm-hmm. But yes, there's a lot going on there.
Yeah, and because, when we were working outside over by the locks, and we were in I can't remember what it's called, basically used to block off the flow of water.
A head gate.
The floating. Yeah, the floating, the head gate, yeah.
Yeah.
And so...
you mean the floating bulkhead?
The bulkhead, yes.
We were on top of it.
Mm-hmm.
Yes.
Yeah.
That's the floating bulkhead, yes.
So, people look at a dam as just this, if they don't realize what it's like inside, it's this big monolithic concrete thing, but there are just all kinds of not only confined spaces, but rope rescue, potential. There's the potential for rescue there because people are working in all these different places. On the fish ladder, for maintenance, in the turbine areas, on the locks. Yeah. So you have to deal with the potential for water rescue.
Yes, which luckily we haven't, because even though we do have work that takes place over water, it's usually inside of a draft tube where it's a closed off area. Now we do work on the river itself, but usually we have a safety boat and we have a whole, we have a BRZ permit to make sure that vehicles can't get to where we're actually discharging water or where the intake is. We have areas delineated where vessels can't come any closer just because they may get sucked in. And so, yeah, there's a lot that goes into just, managing all the different things that are happening at once at this dam. So.
Yeah, I know when we went down, you took us down into the unit that there was an outage during the outage and the rebuilding of that turbine.
Yes.
Just the very, very challenging confined spaces in there.
Yes. And surprisingly enough, we have an area, a very unique area that I showed you. It's called the turbine pit.
Mm-hmm.
It's basically where the main shaft spins and the turbine itself is connected in the bottom portion of this giant. It's a giant hole, basically. And so, yeah, there's something very specific that's called packing. It's basically a type of I'm trying to even think what this is. It's a type of material that's like braided that gets put in certain areas to stop water leakage. But people actually have to crawl into this confined space through two smaller holes. And so these are the challenges that we face, that we've got these very unique areas where people have to go inside and perform work in either a crouching or laying down. Now, we think about this and we know that this is happening. We have to do an AHA that covers all of those hazards, because in an emergency, how will we get that individual out there? We don't even know where. You can't see it from the top. You can only see the individual if you yourself are in that same area. Now, try imagining trying to rescue somebody and you don't know where in that confined space exactly they are. How do you know how many people to send in? How do you know what position he's in to be able to drag him out? So there's a lot of thought that goes into how we perform this work, how many people we're putting in a certain confined space, and what process do we have to be able to get those individuals out. This is something that we have to do with the majority of our work, because it usually involves confined spaces or some sort of, work from a lift at height, from ladder scaffolding. So yeah, there's just a lot to think about in the rescue component.
Yeah, and as Wayne, our school director, always likes to talk about, you need to do that A to Z rescue, not the A to X. Once you get them out of the space, you may still have a long way to go to get them to where you can actually get EMS personnel there, whether you're raising them or lowering them via ropes. So
that's true. Getting them out of the space is just one of the steps we take. But then once we get them out of that space, now how do we get them out of the inside guts of that turbine and out onto the floor where we can package this person and get them, up higher where we can get a higher degree of medical help. So
I was amazed too at the amount of cage ladderways with all the different cranes that you have around and all the different elevated sites there. It's luckily your team is very adept at making cage ladderway rescues there, so they did great.
We've got some really good guys on the team, and some people, they just want to know, how do we get these individuals down? And this is good for me because, well, obviously I want people on the team that want to be there and they, want to learn. So, when we do have these situations, we have a team that's, can work well together, knows what our strengths and weaknesses are. So yeah, definitely the main component is the people on the team and their willingness to learn what needs to be done in case we ever get into an emergency situation.
I think, too, one of the inherent advantages of having an in-house rescue team like that is your people are so familiar with all the hazards and on all the different intricacies of dealing in the areas that they deal with versus like an off-site rescue team coming in.
Right, yes.
If they didn't have a chance to practice there, it'd be a rapid learning curve. So
yeah, or it would be scary to think about, somebody else coming in and us trying to tell them what the problem is and where the individual is. And it just, where we work, we're almost remote enough to where we need to have our own team to be able to extract an individual out of a confined space. But we're also close enough that the last time that we actually had a full exercise with the local fire department, I think it takes them about 13 minutes to get to us from where they're located in Burbank Now, the downside is that their force is all volunteer. So if we were in an emergency and we call and they have no bodies to come and help us, then they have no bodies for, to come and help us. So that kind of puts us in a different situation where now we've got to think about either MedStar, Life Flight, or some other way. And obviously, depending on what, the injuries of the individual would dictate what our next steps would be.
And that's where your EMS and hospital background really has to come in handy there.
It really does, actually. There's another guy on our team that he was a volunteer firefighter for this local department, and he still has an EMT license. So, because of the size of our group, it's to our advantage that we at least have two individuals that have, pretty extensive medical training to be able to, at least determine what we need to do for this individual. So.
You said something too that really, I think, I wish that more people would do what you did. And you said you routinely do joint exercises with your local fire department, which is so important nationwide, because we run into this all the time when we teach confined space classes. Is a lot of industry, it just assumes the local fire department is trained and equipped to perform confined space rescue, when the vast majority
are not
exactly. So.
Yeah.
The fact that you're reaching out, so you know what their capabilities are, and they know what your capabilities are. That's fantastic, because
yes,
just putting 911 on your permit is not an acceptable means to cover rescue. So that's great. You guys are really taking a proactive approach.
We talk to our contractors when they come on site about, they submit these plans, and I'm like, this is great, 911, but do you even know what they're capable of doing? It turns out that we're in a unique area where I guess there's Walla Walla County, Benton, and Franklin County. So all these counties meet, but the response areas are different. So an example would be if I call from the south shore of the dam, if I call 911, it'll go to Burbank. But if I call from the north shore, it'll most likely go to either Franklin or Benton, who have not been out to our facility. And so even our 911 system is also, we have to be careful about, where we're dialing, and if the individual in the control room actually knows, okay, you need to directly contact the local fire department on the Burbank side. And so, yeah, there's a lot of that, coordination that needs to be done also to ensure we get the right response coming to us. So, yeah.
Yeah, and it's like I said, I was very impressed with your team. You've done a really good job of getting people on there that, like you said, want to be there, that are really engaged, that really want to learn, and which is so important with all the unique hazards that you face, that you have to deal with there. So that's fantastic. And I would imagine too, it's got to be a good feeling for all the contractors that are working there during the outages and so on, to know that there's an on-site team that is based there, that knows a hazard that can take care of them when they're there. God forbid something happen.
Yeah, we're lucky in the sense that the way that the Corps and that we like to do business with contractors is we fully expect that contractor to come in with their own rescue team, with their own gear, with their own trained individuals. Which luckily for us, Voith, which is the contractor that's in-house with us right now, they have all of that. But we have a good relationship where we knew that if they were in trouble and they needed our team's assistance for whatever it is in our own powerhouse, they know that we would be willing to share our equipment and our knowledge to, do whatever we needed to do to help that individual, which actually did happen for us once. I want to say it was maybe like 2018 or 17. One of the contractors actually fell from a set of stairs. He fell backwards and ended up hitting his head on, some concrete components. And then our rescue team were able to help their rescue team get that individual out of, it was Unit 2 at the time. But yes, any sort of fall in this area would be pretty bad, because the guts of the dam weren't, or of the generator weren't actually inside of the barrel. It was just like an empty cavity. And so anything that falls in there, the consequences could be much worse had you fallen to a lower level. So yeah, we were lucky that we were able to get that individual help and get him out of there. I think like in less than 10 minutes. just because, our folks are just so ready to jump in and help. So that was one time where it really paid off that our team, with our experience, was there to lend a hand to contractors that hadn't been with us too long and didn't, weren't used to our facility. So that worked out quite well.
Yeah, that's great. Well, then I think, too, one of the other advantages that we've seen is when you have an in-plant team like that, all of your team members are kind of your eyes and ears out there, too. And not only do they perform rescue but since they have the experience as rescuers, they're on the lookout for stuff. They can, the amount of prevention that's there has got to be fantastic for you.
Well, it's good though. I mean, this is where that knowledge from the folks on the team, the guys that are actually doing the work, I rely on their expertise to tell me, hey, we're going to be working on this. And because we know we've been doing this work, these are the hazards that we need to somehow, find a fix for. We need to mitigate these. And that is of a great help to me, because even though I don't do the work, I'm not physically out there welding or doing what these guys do. But the fact that I understand their work helps me anticipate those hazards and helps me, mitigate whatever concerns they have, whether it's scaffolding, working at high confined spaces, or respiratory protection. I mean, pretty much everything you can think of happens at this dam. So it's I have to be like a jack of all trades pretty much, but I rely on these guys and their expertise, to kind of help me help them. So
I was very impressed with the team and yourself when we were out there, and hopefully we'll be back again to train with you guys, because really definitely enjoyed working with all of you.
Yeah, I mean, these guys look forward to every 2 years. They know you guys come out for our 40-hour refreshers. So every year it's like, aren't we due this year? I'm like, no, that's next year. So they're always excited about you guys coming out, and I am too, though, because it's a chance for all of us to just kind of relearn everything, and it just kind of gets cemented deeper in our brains. So.
Yeah. So anything else? I see we're looking at our time here. We're kind of running towards the end of it. Anything that you would like to add, or anything to wrap us up?
I think probably, and if I don't know if this is, this might seem like I was not paid for this endorsement kind of thing, right? But like what you guys do with CMC, your equipment, your instructors, all the guys that have come out to us. I mean, we've been using you for probably I think you were our third or fourth refresher. So I've been using your guys' company for a long time now. And every time you guys come out, whether it's the same instructors or different instructors, it's always such a joy to meet you guys, because you see what we have, and, you work with us, and you can see our unique situations and offer, good ideas for us to be able to implement in our own processes. So I'd like to say thank you for you came out, and I know his name's not really Kloppy, but Kloffenstein, right?
Oh, yeah,
his last name?
Yes, Justin,
Justin, thank you.
Yeah,
I remember seeing Kloppy on his belt, and I was like, what's that about? But anyway, it was really great to meet you guys, and for you guys to see what we do, and be able to, help our unique situations that we've come across. So I just wanted to, say that I'm really amazed with your guys' training, and I always appreciate when you come out there. You're always so enthusiastic, and I think that kind of helps us, feel more, I guess, maybe more confident about our team skills. So, yeah.
Well, thank you very much. Yeah, like I said, we definitely, all of us that have been out there, enjoy coming out there. I just got lucky this year. I got to be the one, along with Justin, that came out and train with you guys. So we really appreciate the opportunity.
Yeah, thank you. And we look forward to having you guys come out again in about a year now.
Excellent.
So,
that'd be great. Yeah. Well, again, thank you so much, Clara, for joining us on the podcast, and hopefully our listeners got kind of their a little bit of a peek into